Well, time to take a look at German field fortifications in World War II. Originally, I had this video planned for 2017 or even 2016, but it just didn't feel right. Now it clearly does. So grab your shovel, your Stahlhelm, and of course your toilet paper, and let's start digging. Since we want to do this the proper way, we need to make sure that you have the basics down before we look at all the different fortifications. This means some general thoughts from German army regulations on field fortifications. And they note, field fortifications increase one's own weapon effect, reduce the enemy weapons effect, and maintain one's own fighting power. The longer they remain undetected, the greater the benefit. Another crucial aspect was Germany's focus on combat effectiveness. As such, for all emplacements, apply the principle of effect before cover. Effect takes precedence over cover. The Pioneer regulation for all arms explains that the effect of firepower could be increased by the proper selection of firing positions, clearing the line of fire, and the establishment of observation and communication posts. Additionally, by using existing obstacles or constructing new ones. Furthermore, hedges, trees, bushes are to be removed only when necessary. Felled trees often block the field of fire. Trees are therefore generally only thinned out of branches. The crowns are left as protection against enemy observation from the air. Of course, it was also crucial to have the proper camouflage, which seems obvious, but you also need to consider the timing here. All fortifications that are constructed according to schedule must therefore be camouflaged before and during execution. Note that camouflage should be started before the work. As you can imagine, doing hard manual labor with pickaxes, shovels and other equipment while also maintaining proper concealment can be a bit of an issue. It is both difficult and time intensive. As such, the regulation notes that the construction process is often easier during the night or fog. As mentioned before, combat effectiveness was crucial. The Germans usually called it Kampfkraft, usually translated with fighting power. This is also related on how the German army saw dugouts. To quote a heading for a subchapter, second, facilities for maintaining fighting power, dugouts. It was of course also crucial to preserve the fighting power of troops and weapons. One paragraph addresses this. Means of maintaining fighting power are digging in, building concealed dugouts or shelters, and preferable camouflage connections backwards and sideways. This could be done in various ways. First, spreading out the entire fortification system in both depth and width. Second, to have rather small individual fortifications as well, since those would diminish the effect of enemy fire. It is explicitly stated that such an arrangement is more effective than a single large well-developed strongpoint. Another way to reduce enemy firepower was the construction of decoy positions. Decoy positions are designed to deceive enemy observers and fragment enemy fire. They are to be camouflaged in such a way that they are still recognizable on photographs or with sharp binoculars, and cannot be distinguished from real positions. Yet decoy positions had to be planned out and maintained as well. Decoy positions must appear occupied, therefore they must not lie dead. Trails, connecting ditches, wagon tracks must also be led to or beyond them. Since we have the basics set, it is time now to look at some field fortifications in more detail. So let us start with trenches. An instruction pamphlet from 1944 basically notes that there are three types of trenches. The fire trenches, which the Germans called Verbindungsgräben or Kampfgräben, meaning literally connection trenches and combat trenches. But be careful here, the literal translation of the first one is misleading, since that is very similar to the English name of the second type. Fire trenches ran parallel to the front line and connected the various positions and outposts with each other. These trenches should be constructed narrow, meaning about 0.4 meters on the bottom and about 0.6 to 0.8 at the top. The depth should be around 1.8 to 2 meters. Furthermore, every 10 to 15 meters there should be a bend. The second type were the communication trenches. These were called Annäherungsgräben in German, literally meaning approach trenches. They usually were laid out perpendicular to the front line and were meant to enter and leave the fire trenches. Communication trenches in their dimensions were similar to the fire trenches. namely about 0.4 meters on the bottom, but at the top about 0.8 to 1 meter, hence 0.2 meters wider. The depth should be around 2 meters. Additionally, it is noted that regularly should contain small trenches that protect against tanks, which brings us to the final type, namely Panzerdeckungsgräben, which literally means tank cover trenches. Note, these trenches should not be confused with anti-tank ditches. These trenches were built that tanks could roll over them and still protect the personnel inside. The design was like those of fire trenches, and they were built near installations that didn't provide cover against tanks. Here you see an example position. There would be barbed wire or other obstacles in front of the trenches. Here is a machine gun position. These small elements were dug out to take cover, and these parts are foxholes for 2 riflemen. A bit further behind is the shelter. Be aware that there were several ways to classify trenches. For instance, the US Field Manual from 1940 had 2 systems, one by direction and the other by employment, whereas the 1944 Field Manual went by layout, differentiating between special and standard trench, whereas the latter was used for fire and communication trenches. Anyway, let us move on. Ideally, such a trench position is protected by an alarm system as well, and this is how it looked like. Now these elements here were the sound generators, which are usually tin cans, which were connected with wires. Note that they should emit a buzzing sound and not a loud noise. To quote, "When the wire is touched, it is set in vibration, which is transmitted to the sound generator, tin can, acting as a soundboard. The guard is alerted by a clearly audible buzzing sound. The same effect is achieved when pieces of wire fall onto the tension wire when cutting through the wire obstacle. If the tension wire is cut through, the sound generator falls down." The construction details are quite interesting. They also particularly include which tin can is the loudest or how to increase its volume. The sound generator consists of a long, narrow tin can. Asparagus can, loudest buzzer. Increase the means of sound generators from 2 cans according to illustration number 2. Next, let us look at anti-tank ditches and tank traps. The anti-tank ditch from the side looked like this. The angle of the ditch should be at least 55 degrees. This triangular shape should result in the tank either doing a nosedive into the ground, ideally damaging its gun, or fall into the ditch after the front had crossed. Now in case you think that such a ditch can be easily spotted, you probably never sat in a tank. As such, you might want to watch this video first, where I sit in a bow gunner position of a T-34 while it drives with an open driver's hatch, which is not recommended in combat. Also be aware if the enemy is firing at you, there's smoke, burning frackages and explosions going off all around you. You probably see far less in such a situation as well. In terms of constructing the anti-tank ditch, there were 2 stages. In the first one, the width was about 3.5 meters. Whereas for the second stage, it would be 4.5 meters. This stage was also provided for 2 types of soil. For the weaker ground, it was required to use wood to stabilize the ditch properly. Yet let us look at the tank trap. This one comes with a preface. Tank traps should only be set up as an addition to other barriers that are located before the front line in their own firing range. For instance, setting up a trap on a forest road that cannot be bypassed by tanks in front of a wire obstacle. Hence, this was not about destroying the tank, but to render it at least temporarily immobile to increase the chance to hit. Here you can see the cross section. Notice it had a box shape. The bottom width was about 5 meters, the top width about 6.5 meters, and the depth about 3 meters. To cover the trap, wood was used, and the previously removed topsoil should be put back into position again. The next one requires a bit more material, but also provides more protection, namely a MG Ringstand aus Stahlbeton, literally meaning machine gun ring stand out of reinforced concrete. This one you see right here was filmed at the Oder Wartebogen, or often called Ostwall in Poland. If you never heard of the Ostwall, by the way, you might want to check out this video from my second channel that contains many videos at museums, historical sites, and also interviews with various experts. Now let us look at the blueprint. As you can see, it has a rather simple setup. The opening diameter was about 0.8 meters, where angle steel should be used as a guide rail. Additionally, there were built-in platforms as well, and a wooden one that could be moved. It was designed in a way that, with a bipod mount, you can go from anti-air combat to horizontal fire without having to reposition. In terms of supporting weapons, it was noted that the MG34, 42, 0815 and MG30 could be used in the ring stand. Additionally, 2 captured and checked machine guns are listed as well. Furthermore, anti-tank rifles, the 5cm mortar, flamethrowers, the scissor scope, and tank turrets from captured tanks were supported as well. Note that the construction of such a fortification would take about 25 days, for about 10 men, working 8 hours a day. About 55 cubic meters of earth would have to be moved. The material required was as follows: 14 cubic meters of gravel sand, 90 square meters of wooden formwork, 4.5 tons of cement, 4 kilograms of nails, 750 kilogram round steel, about 230 meters of wires, 150 meters of wooden beams, and with an estimated total weight of 25 tons. Which is actually quite a lot if you consider how small these positions actually were. The next position is for a Nebelwerfer, namely the 28-32 cm Nebelwerfer 41, which was of course covered in my video on Nebelwerfer. If you haven't seen it, check it out. Anyway, here we have the basic outline from the top. The enemy is towards the right side. The Nebelwerfer 28-32 cm should be positioned here. The space for the Nebelwerfer should be about 5 meters in length. Now the 2 larger areas on the left and right are for the ammunition. They should have a depth of 1.3 meters. The areas further away from the enemy, namely here, are for the cover of the crews. These should have a depth of 1.8 to 2 meters, so regular trench depth. Note that the trenches at the front are less deep, but the earth banks provide additional protection. Also during the construction, keep in mind, during the entrenchment work, the werfer are to be placed about 5 meters in front of the plant covers so that the battery is always ready to fire. The drawings should only be taken as a guide. The details of the positions are to be developed irregularly and adapted to the respective terrain. Next, let us look at an artillery position, namely for the 10.5 cm leichte Feldhaubitze 18. The area of the gun should be around 5 meters wide and 6 meters in length. The position would be about 0.5 meters deep, yet the trenches should deepen, with 1.25 meters on the left and 1.1 meter on the right side. Additionally, there would be locations for the ammunition at various points located on the right side. Whereas dugouts for personnel should be located on the left. The estimated man hours here are around 110 hours, so 22 hours for 5 men. Finally, let us look at the Kampfwagenstand, so a position for a tank. Here we have the view from the side and the top as well. As you can see, the dugout is placed directly into the fire trenches and allow the infantry to pass by. The length before the ramp is given with 8 meters. Considering that even a Königsdieger had a length of 7.4 meters, 8 meters should be sufficient, especially for smaller tanks like the Panzer IV. The length of the ramp was given with 4.7 meters. The depth was around 1.6 meters. The walls were made of fascines, which are bundles of wood or other material. They were held in place by stakes. The whole position required the removal of about 80 cubic meters of earth. The required material was about 121 meters of round lumber posts, 150 meters of wires, and 40 square meters of fascines. The construction time was about 5 days for about 9 men. Note that the vast majority of fortifications and other elements listed in the pamphlets and manuals are of non-combat nature. To give you just a few examples, there are plans and instructions for various kinds of roads, dams, log causeways, wells, water filters, latrines, 8 different types of floors, windows, doors, and much more. Well, the next time you need to dig in, you know some basics. A big thank you here to my Patreon and subscriber supporters that make videos like this possible. Special thanks to Andrew for reviewing the script. As always, sources are listed in the description. Thank you for watching and see you next time.